Welcome. Today we're going to learn binary search in the simplest, clearest way possible. We'll start with the basic idea behind searching, then slowly build our way up to a complete Python program. Take your time, follow along step by step, and by the end of this lesson, you'll understand exactly how binary search works and why it's so powerful. Searching is just the process of trying to find something inside a list. It's no different from looking for a particular book on a shelf or finding a contact in your phone. Here, we're working with numbers. Imagine the list shown on the right. Our goal is simple. We want to find the number 6. Let's see how we might do that. Before jumping into clever techniques, let's be clear about what we're actually trying to do. First, we'll always work with a sorted list. Small numbers on the left, big numbers on the right. Then, we want to figure out exactly where a number is located inside that list. And most importantly, we want to learn the fastest way to search, so we don't waste time checking everything one by one. The most basic way to search is to start at the beginning and check every number until you find the one you want. It's simple, but it's slow, especially when the list gets large. If you had 1,000 numbers, you might end up checking all 1,000 before finding your answer. We need a smarter method. Binary search is that smarter method, and it works because the list is sorted. Instead of starting at the beginning, we jump straight to the middle. If the middle number is bigger than what we want, we go left. If it's smaller, we go right. Every step cuts the list in half, which makes this method incredibly fast. You'll see that pattern clearly as we go through examples. Let's begin with a small warm-up example. Our list has only 3 numbers. The middle number happens to be 6, and that's exactly what we're searching for, done in one step. Small lists are easy, but the same idea works beautifully on larger ones too. Now let's try a longer list. Our target is 7. We start by checking the middle, which is 5. 7 is bigger than 5, so we ignore everything on the left and move to the right half. Now, the middle of this new half is 9. 7 is smaller this time, so we move left. And finally, we land on 7, our target. Notice how each step narrowed the search. This is exactly why binary search is so efficient. All right. Now, let's take a closer look at the Python code for binary search. Don't worry if it looks a little long. We're going to walk through it slowly, line by line, so you understand exactly what's happening. We start by defining a function called binary search. It takes 2 things: the list we want to search and the target number we're trying to find. Inside the function, we set up 2 pointers. Left starts at 0. That's the beginning of the list. Right starts at the last index. That's the end of the list. Next, we start a loop. This loop keeps running as long as there's still space to search. In other words, as long as left hasn't gone past right. Inside the loop, the first thing we do is calculate the middle position. We add left and right, divide by 2, and use integer division so we get a whole number. That gives us the index of the middle value in the current search range. Then we check the middle value. If the value at that position is exactly what we're looking for, great, we return that index immediately. If the middle value is smaller than our target, that means the target must be somewhere on the right side. So we move our left pointer forward to mid +1. If the middle value is larger than our target, the target must be on the left side, so we move our right pointer back to mid -1. And if we finish the entire loop without finding the target, we return -1 to show that the number isn't in the list. So, at a high level, this function keeps narrowing the search space, checking the middle each time, until it either finds the number or runs out of places to look. Let's take this code apart one idea at a time. We begin by setting left to the first index and right to the last index of the list. As long as there's still space to search, we calculate the middle position using integer division. Then, we check the value at that middle position. If it matches what we're looking for, we return the index immediately. If it's too small, we move the left pointer forward. If it's too big, we move the right pointer backward. And if the loop finishes without finding our target, we return -1 to show that the number isn't in the list. Let's visualize the whole process. At the start, left is at the beginning of the list, and right is at the end. We calculate the middle, compare the value, and adjust our pointers. Then we repeat the process with a smaller range. Each step cuts the search space in half, which is what makes binary search dramatically faster than checking every number. Binary search is fantastic, but it only works under the right conditions. First, the list must be sorted. Without that, the method simply doesn't work. Second, it's extremely efficient for large lists. Even a list of 1,000 items only needs around 10 steps. And finally, because you only check a few numbers instead of all of them, it saves a lot of time and computing power. But it's extremely efficient and fascinating. Let's quickly look at some common mistakes beginners make. The first mistake is using binary search on a list that isn't sorted. That will always give wrong results. The second mistake is calculating the middle incorrectly. Make sure you use integer division so you get a whole number index. And the third mistake is forgetting to move your pointers. If left or right never changes, your loop will run forever. Keep these in mind as you practice. Now it's your time to test your understanding. Try solving these simple problems on your own. Write down each step, the left pointer, the right pointer, the middle position, and what happens in the comparison. Seeing the pattern on paper for a few examples will help you fully understand how binary search behaves. Let's recap what we've covered. Binary search is incredibly smart because it checks the middle first and removes half the possibilities at each step. It's also extremely fast compared to scanning from left to right. And once you follow the steps carefully, it becomes easy to understand and even easier to apply in real programs. What feels tricky at first becomes second nature with just a little practice. Great job completing this lesson. You've just learned one of the most important algorithms in computer science. Binary search is used everywhere, from finding contacts in your phone to searching huge databases. Keep practicing, and you'll be using it confidently in no time. If you enjoyed this lesson, don't forget to like, subscribe, and check out more Python tutorials. See you in the next one.